Welcome to the 2023 QCAA multiple choice questions for math methods. We're looking at paper 1 in this video from the external exam. Question 1, e to the ln x is the equivalent to, I started it by saying, well, let's let y equal e to the ln x. Now there's a couple of ways I can go from here. I can either rearrange this into log form, or I can take the log of both sides. So I've said let y equal e to the ln x. If I rearrange that into log form, I've got ln y equals ln x. So y must equal x. Therefore, I can make this statement here that x is equal to e to the ln x. Answer C. Okay, question 2. We've got if f of x is equal to e to the 6 minus 2x, determine the value of f dash of 2. So we need to find the derivative to begin with. The derivative of that 6 minus 2x gives me negative 2. So that comes out the front. Then I've got e to the 6 minus 2x. That part there doesn't change. Substitute 2 into this and I should be able to solve it. 6 minus 2, there's 2 there, and that gives me negative 2, 6 minus, well, that's going to be 4, e to the 2, and that, there it is. In this case here, that corresponds to answer D. So question 3 says a bag contains 10 buttons of the same shape and size in different colors, 5 blue, 3 green, and 2 red. If 3 buttons are randomly drawn from the bag, which probability can be calculated using the binomial distribution? And I know from my formula sheet that the binomial distribution is this. In this question we've got n being the number of trials, which is 3, and the number of successes r is going to be also equal to 3. If we look at the answers there, we've got A, the probability of 3 green with replacement. Can we use the binomial distribution for that? Well, let's test it out. So if we know that the probability of 3 green is what we're after, and we know that the using this information here, I can set up as 3 choose 3. My probability of success in this case, I need to know that. Well, probability of success, we want green. How many objects are there? We've got 10 buttons altogether, so there are 3 of those which are green. So probability of success is 3 out of 10. And that's going to be raised to the power of 3 from this over here. And then our probability of failure, in this case, or 1 minus p, you've got 7 out of 10. And that is going to be to the power of, well, it's going to be 3 minus 3, n minus r. So that's going to give me 3, sorry, that's going to be not going to give me 3. 3 minus 3 is going to give me 0 here. So we end up with this. If you're comfortable with that, I think that in the exam, you would probably say, yes, A works, therefore I can then move on to the next question. If you wanted to then explore some of the others, I suggest maybe you could set up a tree diagram or something like that for testing out B, blue or not blue. So you're going to get 5 out of 10 for blue, or 5 out of 10 for not blue, and then once you don't replace a button back in the bag, the probability changes. So to get another blue, it's now 4 out of 9. So you can see already without replacement changes the probability. So therefore B is going to be incorrect, and C, I believe, probability of 2 green, 1 red without replacement, that also is going to be incorrect. So the probability of each outcome for a binomial distribution must be, they must not change, they must be the same. So in this case here, part A works really well. I would have left it there and just gone straight on to question 4. The gradient of the function f of x is given by 20 over x cubed. The derivative of our function is given by 20 over x cubed. Another way to write that would be x to the power of -3. Therefore, our original function, f of x, is going to be the integral of this. And then we can simply integrate that. So what do I do when I integrate? I'm going to write 20x, adding 1 to that gives me -2. I'm going to divide by that power there, gives me over -2 there. And I can simplify this to get -10 x, well, to the power of -2 plus c. Don't forget the plus c. I should have put it in this step here. That corresponds to answer C. Question 5. Determine the integral between 1 and 3 of 1 over 2x dx. So we've got a definite integral in this case here. Then I know that the integral of 1 on x is going to be ln x. So I'll leave my half out the front, and then I'm going to write in my ln x between my lower bound of 1 and upper bound of 3. And then I am going to substitute 3 into here. So ln 3 minus ln of 1. Now you should know that the ln of 1 is going to give you 0. So this is 1 minus, this is ln 3 minus 0. So we end up with a half ln 3, which is answer D. Okay, question. Substitutions for h are used to estimate the limit of a to the h minus 1 over h. As h approaches 0, which sequence is the most appropriate? You're looking for something that approaches a limit. You want this to approach a limit here. So for a, we can see that this is a sequence that is, well, -2, -1.5. These values are getting smaller. 1/4, 1/8. It looks like it's going down. If I were to keep following that sequence, it would probably approach 0. That's what that seems to be doing there. B, this one here, we've got -0.05, -0.1, -0.2, -0.4. These look like they're doubling, but they're heading in the negative direction. So it's kind of getting bigger in that negative direction. So this is approaching, something really big in that negative direction. So that's negative infinity. Here, similar things happening for C. 2, 1, 0, -1, 2, 3. So these numbers are going to get larger, but in that negative direction again. So that looks like it's approaching negative infinity. And D looks like it is approaching, similar to B and C, approaching some infinitely large number, but this one's going to be in the positive direction. 1, 2, 3, 4. So these are all sort of approaching positive or negative infinity. The only one that seems to be approaching a particular value is A. So in this case, A is our correct answer. And question 7, determine the mean of the continuous random variable x with the probability density function f of x equals 1 over 8x. Well, for this question here, again, you can refer to your formula sheet for our definition of our expected value. So what we're actually doing is determining the mean between 0 and 4 of x. Comes from here. Multiplied by p of x, which is given in the question as 1 over 8 x dx. If I take that 1 over 8 out the front, I get this, and then multiply x by x gives me the x squared. So I'm now going to take the integral, so I'll leave that 1 over 8 out the front, and I'm going to integrate this. I've got x cubed over 3 between 0 and 4. And if I simplify that, I do get 8 over 3, and that is answer number D. Question 8. A sample size of n was used to estimate a population proportion. An approximate margin of error of 3% was calculated using z equals 1.96. Given the sample proportion was 0.6, determine n. Well, we know what our margin of error is in this case. They give you that as 0.03, and we also know what that should be using our formula sheet. And we should get this. We know our margin of error, that's given. We also know some of these other values. We can set this up as an equation. 0.03 is equal to 1.96 square root of p in this case is 0.6. 1 minus p is going to be 0.4 over n. So we can now rearrange this and solve it. It seems a bit complex to solve, but if I look at simplifying this, and then I've got this square root 0.6 times 0.4 over n. If I rearrange that, simplify that, I should get n is equal to 0.24 over 0.03 over 1.96, and that, 1.96, forgot the squared there. I got, that should be answer B. I got B for that one. Just be careful with that one. I looked at answer D. D's a real distractor. You'll notice that in all the multiple choice questions that you do in these QCAA exams, there are distractor questions which are intentionally put in there to sort of make sure that you really know the correct answer. D looks very close to B, and if you're rushing, you just might meet, there's just a decimal point difference between those two answers, so be careful for that. But I believe the answer is B for question 8. Question 9 rather. Now we've got to determine the integral of pi, the integral between 0 and 3 of pi sine pi on 3x dx. So let's just get straight into this one. We're going to first of all integrate. So we've got the negative pi cosine of pi over 3x, and that's all going to be all over pi over 3. Just to make sure I've done that correctly, the integral of sine becomes cosine, so negative cosine, so that's why I've got my negative there. I'm happy with that. Then I've got to divide by the derivative of what's in this bracket here. That's pi on 3, so I've got the brackets correct. That's great. The only thing that's missing is my lower bound and upper bound between 0 and 3. Look at how we can write this a little bit differently to maybe make it simpler for us. So we've got negative pi cosine pi on 3x multiplied by, now I can write this as 3 over pi, and what that does is that just cancels those out there, and I'm really just left with negative 3 cosine pi over 3x between 0 and 3. So there's my integration there. Now, and once you do that substitution, you get negative 3 cos pi, because the 3's will cancel here, and this will become negative 3 cos 0. So if I work out negative 3 multiplied by cosine of pi, well, that's going to be negative 1, and then I've got negative 3 cosine of 0. In this case it's 1. So this is what we end up with, negative 3 multiplied by negative 1, which is just 3. Now the two negatives here are going to make a positive 3, So we have 6, and the answer for that one, I believe, is B. Okay, question 10, our last question of the paper 1 multiple choice exam. The continuous random variable y has the probability density function f of y is equal to 1 plus y, where y is greater than or equal to 0 and less than or equal to root 3 minus 1, and 0 otherwise. So we're asked to determine the probability that y is greater than or equal to 0 but less than or equal to a half. Well, in this case here, we can set that up as an integral between our lower bound of 0 and our upper bound of a half of our 1 plus y, which information which is given in the question. We can integrate that with respect to y. So because we're integrating with respect to y, we're going to put a dy on the end here. So we're going to integrate this as we have with what we've done previously with dx, but in this case we've got a dy. We're going to end up with integral of 1, which is going to just be y, plus the integral of y, which is going to be y squared over 2, and our bounds are 0 and a half. So now we're going to do some substitution here. So we've got a half plus a half squared over 2, and then we're going to substitute 0 into there. So really we're subtracting 0, so we're done. So we can just simplify this here. So we've got a half plus, now we've got a half squared, that would be a quarter divided by 2, same as multiplying by a half. So we've got a half plus an eighth, and in this case here that should be 5/8, which is answer C for question 10. So that's it for the 2023 QCAA multiple choice questions, technology free. Thank you.